section 6.2, the adding, subtracting rational expressions. I want to do a few more examples. That stuff is somewhat tricky. So still adding, subtracting rational expressions. Chapter 6. So basically, we're kind of floating around these two sections right now. So just kind of recap of what we've been doing. A few examples. Let's say I have this problem. I want to add 5 over 5 minus z plus z over z minus 5. So we agreed on something here. Although those denominators do not look the same, they look very similar, right? There is a little trick that we can do. Feels like, and this is what we've been doing for the past few days, that I should be able to flip around the minus. And what happens if I flip around the minus? The sign changes. So that's what one of those tricks that we talked about. If you flip around the minus, the sign changes. So now denominators are the same, so it's just 5 minus z, and the numerator is also 5 minus z. So what does that equal to? 1. So if the numerator is identical with the denominator, the answer is 1. So it's one of those little tricks that we talked about. Here's another case. 2m over m minus n plus 2n over n minus n. Go the other way. So what should I do here? Yeah, flip them. So again, if we flip them around the minus sign, the sign of your entire expression becomes negative. So therefore, we end up with 2m over m minus n minus 2n over m minus n. And when you put them together, you just subtract the numerators. You keep denominator the same. Can you just cross out little m and little n? Can I just cross out the little m's and the little n's separately? Or would that be a bad thing to do? Or how would you proceed? What should I do next? Factor the 2 m minus n over m minus n, and then we can cancel the entire factor of m minus n. So we get a 2. Is that okay? All right, so it's kind of on the same theme about flipping. Sometimes you can just flip an expression to get your denominators to line up. Here's another similar case. Not the same, but another one of those little tricks. So I have x squared over x plus y minus xy, and in the second denominator, I'm going to have negative x, negative y. So what should I do here? Are you all right? So what should I do here? Yeah, I can factor out a negative. That makes it a positive, so then you have a minus and a minus. That's a plus, right? these two minuses will give me a plus in the middle. So pull out a negative, and then that's x squared over x plus y plus xy over x plus y. So same denominator. Is that okay? I can pull out an x because you should always try and reduce, and we can only reduce through factoring. So pull out an x plus y over x plus y. So I can reduce by x plus y. Let's just put a little x. Yeah, so that was a negative sign. Yeah. And then those two negatives became a positive, so that's why that sign changed. And then you just proceed. So these are those little tricks when you can manipulate your denominators just a little bit to get them lined up. So questions on this? Oh, that's a mess. Is that okay? All right, so let's do some more examples. A plus 5 over a squared minus 9 plus a plus 4 over a times negative a minus 3. So denominators are different, right? We'll have to find the LCD. In order for us to find the LCD, we have to do some factoring, right? How would you factor this first denominator? Right, so first denominator breaks down into a minus 3, a plus 3, right? That's the difference of squares. Now, in this second denominator, just think about, because you're going to have to find the LCD between the first denominator, that's a minus 3, plus 3, and the second denominator. Can you do any of those little tweaks with the second denominator to make it a little closer to the first one? What can we do without those two negatives? Yeah, we can pull out the negative, right? Just a plus 3 with a minus. So basically that creates an extra negative with the second fraction. So what kind of sign we're going to have in the middle? I mean, you have a positive, then this negative can trickle out all the way up front. So basically the sign between these two fractions will become a negative if you pull out that one negative. So basically it becomes negative a plus 4 over a and a plus 3. So that saves us a little bit of hassle of finding the LCD. So remember, to find the least common denominator, I have to take all different factors. So what are my different factors in there? What do I need in my LCD? Yeah, but what is my LCD? What am I going to end up with in the denominator? A and a plus 3, right? So I need all factors. I don't need to list a plus 3 twice, because remember, we're just taking the highest power, so all powers are 1, so we're just taking 1 of each. But yeah, what Nick was saying, that when you compare the first denominator with the LCD, it's missing an a, so we have to multiply it by a over a. And when you compare the second denominator with the LCD, it's missing a minus 3. So I have to multiply the second one by a minus 3, minus 3. So it's a plus 5 over a minus 3a plus 3 times by a over a minus the second expression, a plus 4 over a times a plus 3, and we're multiplying that by the missing term, a minus 3 over a minus 3. So that brings them to the same denominator. Is that okay? Now, when we got that denominator to equal between these two expressions, it almost doesn't matter what it is. I'm not even going to look at the denominator at the very end of this problem when I'm trying to reduce it. So that's the only time where I'm actually going to pay attention to what my denominator is. So I'm just going to focus on my numerator. So what's my numerator? It is a times a plus 5 minus a plus 4 times a minus 3 divided by whatever the denominator is. So I'm just lazy. I'm just going to write LCD. Because I don't care what it is at this point. My job is now to simplify the numerator. So denominator doesn't even matter. Right? Because down the road, I want to simplify the numerator and factor it, and then hopefully to reduce it. Then when it's actually going to matter what denominator is. So the rest is really exercise in foiling and opening up parentheses and combining like terms, which you all know and love. Right? That's the easy part. You distribute the a, becomes a squared plus 5a, right? And then you FOIL these two parentheses, order of operations, multiply before subtract. So we're going to keep a minus. And when you FOIL, you get a squared minus 3a plus 4a minus 12. Still in the parentheses because of the negative. Distribute the negative. So minus a squared plus 3a minus 4a. We could have combined like terms. Doesn't matter when you do that. So how you get your numerator to work is really up to you. It doesn't matter exactly which order you follow as far as combining like terms first to last. Is that okay how we got here? Can I simplify that numerator? So what's going away? A squares are gone. Then combine like terms, you have 5a plus 3a minus 4a. That's 4a plus 12. Well, let me put the denominator there now. It's a times a minus 3, a plus 3. Are we done? Can I do anything else? Yeah, factor out of 4. Because again, you should always try to factor and reduce. When you factor out of 4, it gives you 4 times a plus 3 divided by that LCD. So then you see that there's a common factor between the numerator and the denominator, and we can always cross out common factors. So this is why we have to keep things factored till the very end. So in the end, it is 4 over a times a minus 3, and that's all. And you can keep that denominator factored. You don't need to distribute the a. If you do, no big deal, but that's fine. That's the answer. So how did we get here? Any questions from that? We factored, we tweaked one of the denominators just a little bit, Then we took all distinct factors that we saw. Then we figure out what each fraction was missing. We multiplied by what's missing. Simplified the numerator. Factored, reduced. Is that good? All right. Here's another one. N over m squared plus 2mn plus m minus 2n over 4mn. So first thing we should always do is to factor. So n over, pull out an m plus 2n plus m minus 2n over 4mn. So again, the least common denominator is the list of all distinct factors that we see. So when I look at those both denominators, I see a 4. Do you all see a 4 that go in the LCD? Yes, if you see it, it goes in the LCD. I see an m. I see m twice, right? M is a factor in the first denominator, m is a factor in the second denominator. So I need an m just once, because again, you're just taking the highest powers. Then I see a single n that goes in, and then I have m plus 2n that goes in as well. So again, you pulling together all distinct factors raised to the highest powers that you see. That was the concept of the least common denominator. So then just compare your original denominators with the LCD, figure out what's missing. So what's missing in the first one? 4n, right? So multiply by 4n over 4n. What's missing in the second one? What is missing in the second one? You compare the second denominator with the LCD. Yeah, m plus 2n. Is that okay? Okay, so these two expressions have the same denominator, so again, it doesn't matter what it is at this point. But what's in my numerator? It's n times 4n, so that's 4n squared, plus the product of m minus 2n, m plus 2n. Well, no, I mean in the numerator, because I want to have my numerator factored. In order for me to factor my numerator, I do have to open up all the parentheses, because it's not factored yet. Is there a quick way to multiply m minus 2n by m plus 2n? What is that equal to? Difference of squares. So you square the first, you square the last with the minus in between. That's your difference of squares formula, right? A plus b minus b is a squared minus b squared. So these two cancel. And we are down to m squared over, well, what is the denominator? 4mn m plus 2n. Are there any common factors between the numerator and the denominator? M. So I can cross one of the m's out. So that m cancels with that. you still have 1 left in the numerator. So the final answer is m over 4n plus 2n. There's nothing else I can do with that. Well, because again, when I get to this point, I want to simplify my numerator and hopefully get it factored, because it's not factored right now because that's plus. So in order for me to do that, I have to open these two parentheses. Well, then I just recognize that they only differ by a sign in the middle. So this is my a minus b plus b form. So I can use difference of squares to multiply that fast. This is my a minus b, a plus b equals a squared minus b squared case. So I do it faster. Other questions on this? Does that make sense? So again, the process, factor first, find the LCD by pulling together all distinct factors, figure out what's missing in each denominator, so multiply by what's missing, and then mess with your numerator and hopefully reduce. You do the same thing with the numerical fractions, right? Except for factoring, you kind of guess your least common denominators, but if it's something necessary, you do have to factor, and you kind of follow the same algorithm. All right, let's do one more. So 7n squared plus mn minus 8m squared divided by m squared minus 2mn plus n squared minus 8m over n minus m. So let's do some factoring. How would you factor that first denominator? What? Sure. What does that look like? No. What does that look like? No. But you have a perfect square, and the double product in the middle. What is that? This is one of your favorite formulas. Which one? Square root of difference, because of the difference. So yeah, that's just m minus n squared, right? There are two of them there. They're identical. So this is your a minus b squared formula. You need to recognize those. So one of them is m minus n, the other one is n minus m, right? Are they the same? No. So we do have to do some kind of a flip. So you actually have two options. You can flip the second one and change the sign, as we were doing earlier today. Or I told you that you can always flip inside the square. Flipping inside the square doesn't change anything, right? Because if you flip around the minus, it changes the sign, but you're still squaring it, so that doesn't matter. So you have two options. You can either just write it, that's same as writing n minus m squared, or write m minus n in the second fraction and change the sign in the middle. Doesn't matter which way you want to go. So which way do you want to go? Okay, so let's flip the square. You can always flip inside the square, makes no difference. It's the same expression. The reason for that, do you agree that m squared minus 2mn, don't write this down, n squared is the same as n squared minus 2mn plus m squared? Can I interchange m squared and n squared? In other words, is that the same thing? Well, this factors into m minus n squared. This factors into n minus m squared. So they have to be the same. It doesn't matter which way you put your squares. So anyways, you can always flip inside the square. So if we do that, nothing changes except for the order of subtraction in that first denominator. So now at least my variables are lined up in the same way. So that saves, that makes my LCD a lot shorter than it would be otherwise if I didn't do that flip. What is the LCD here? Squared. You have two factors, you take highest power, so it's n minus m squared. So that means the first fraction is happy, it already has the denominator. What is the second one missing? How am I going to make the second denominator into the LCD? Right, so you just multiply by what's missing, which is another factor of n minus m. So this way it's n minus m squared. So now if I put everything together, 7n squared plus mn minus 8m squared minus 8m times n minus m. If you put everything together. So now it becomes an exercise in opening up parentheses, combining like terms in the numerator, and hopefully getting it factored and reducing with something. So let's just do that. 7n squared plus mn minus 8m squared. Then distribute. Negative 8m gives you negative 8mn plus what? 8m squared. So what can we do about that numerator? Can I simplify that? So what's going to happen here? Yeah, the 8m squared cancel. And when you combine like terms, you get 7n squared. Then you have mn minus 8mn, so minus 7mn. Is that okay? Now can I factor? Can I factor and reduce this thing? Can I factor that numerator? How would I factor that numerator? Yeah, 7n is the common factor, and then it's n minus m over n minus m squared. So now there's the common factor of n minus m, and I can cross that one out. leaves us with 7n over n minus m. And we're done. So questions on this one? Same idea. Factor first. If necessary, tweak your factors just a little bit to make your LCD smaller. So we did that. We did a flip. Find the LCD, multiply by what's missing, simplify the numerator, factor the numerator, and hopefully reduce. Because we can only reduce fractions through division. That's why everything has to be factored in order for us to reduce a fraction. Yeah? Does that make sense? Oh yeah. Oh, yeah. All right, good. Well, let me see that. Oh.